Chapter 1.6.5 Storage Classes. A storage class in Kubernetes allows administrators to define different classes of storage, which can map to different quality of service levels, backup policies, or other arbitrary policies. Kubernetes itself does not dictate what these classes represent. This concept is similar to profiles in other storage systems. Familiarity with volumes and persistent volumes is recommended when working with storage classes in Kubernetes. It provides a flexible way for administrators to describe the storage options available in their cluster. Storage class objects. Each storage class in Kubernetes includes the fields provisioner, parameters, and reclaim policy. These fields are essential for dynamically provisioning persistent volumes to meet the needs of persistent volume claims. The name of a storage class is crucial as users can request a particular class using the name. Administrators define the name and other parameters of a class when creating storage class objects. Administrators can also set a default storage class that applies to PVCs, not specifying a class. For further information, refer to the persistent volume claim concept. An example of a storage class is shown in storage class low-latency.yaml. Default storage class. In Kubernetes, you can mark a storage class as the default for your cluster to be used when a persistent volume claim, PVC, does not specify a storage class name. If more than one storage class is marked as the default, the most recently created default storage class will be used. It is recommended to have only one default storage class in your cluster to avoid confusion. However, Kubernetes allows for multiple default storage classes to allow for seamless migration. If no default storage class is set, you can still create a PVC without specifying a storage class name. In this case, the storage class name will remain unset until a default storage class becomes available. If you do not have a default storage class and decide to set one later, existing PVCs without storage class name will be updated to match the new default storage class, except for PVCs with storage class name set to. To continue using a PVC with storage class name set to while having a default storage class, you need to manually set the storage class name of the PVC to. Provisioner. Each storage class in Kubernetes has a provisioner that determines the volume plugin used for provisioning persistent volumes, PVs. It is necessary to specify this field, but you can choose an external provisioner in addition to the internal ones provided. External provisioners are independent programs that follow Kubernetes specifications and allow for more customization. The repository Kubernetes SIG/SIG storage-lib external provisioner contains a library for creating these external provisioners, and examples such as NFS can be used with external provisioners when internal options are not available. Third-party storage vendors may also provide their own external provisioner. Reclaim policy. Persistent volumes created by a storage class will have a reclaim policy specified in the field of the class, either delete or retain. If no policy is specified, it defaults to delete. Persistent volumes created manually and managed via a storage class will retain the policy assigned at creation. This ensures consistency in how storage resources are managed and reclaimed within a Kubernetes cluster. Volume expansion. Persistent volumes can be expanded by editing the corresponding PVC object and requesting a larger amount of storage. Only certain types of volumes support expansion, depending on whether the storage class has allow volume expansion set to true. It is important to note that volume expansion can only be used to increase the size of a volume, not decrease it. Mount options. Persistent volumes dynamically created by a storage class will inherit mount options specified in the class's mount options field. If the volume plugin does not support these options, provisioning will fail. Mount options are not verified in the class or PV, so if an invalid option is specified, the PV mount will also fail. Volume binding mode. The volume binding mode field in Kubernetes controls when volume binding and dynamic provisioning should occur. By default, the immediate mode is used, which means that volume binding and provisioning happen once the persistent volume claim is created. However, for storage backends that are topology constrained and not globally accessible from all nodes in the cluster, this may result in unschedulable pods. To address this issue, cluster administrators can specify the wait for first consumer mode, which delays the binding and provisioning of a persistent volume until a pod using the persistent volume claim is created. This mode ensures that persistent volumes are selected or provisioned based on the pod's scheduling constraints, including resource requirements, node selectors, pod affinity and anti-affinity, and taints and tolerations. Certain plugins support wait for first consumer with dynamic provisioning, such as CSI volumes, provided the CSI driver supports it. The use of node name in the pod spec should be avoided when using wait for first consumer, as it may cause the PVC to remain in a pending state. Instead, node selectors for kubernetes.io/hostname should be used. Allowed topologies. When using the wait for first consumer volume binding mode in a cluster, there is typically no need to restrict provisioning to specific topologies. However, if necessary, allowed topologies can be specified. An example is provided in a YAML file, which demonstrates how to limit the topology of provisioned volumes to specific zones. This should be used instead of using the zone and zones parameters for supported plugins. This method provides more flexibility and control over volume provisioning in the cluster. Parameters. Storage classes in Kubernetes define parameters for volumes belonging to the class, with specific requirements based on the provisioner in use. Each storage class can have up to 512 parameters, with a total size limit of 256 kips. For AWS EBS, the in-tree storage driver for Kubernetes was deprecated in versions 1.19 and removed in 1.27, with the recommendation to use the out-of-tree driver instead. Similarly, AWS EFS storage can be configured using the AWS EFS CSI driver. The NFS storage class can be configured using either the in-tree driver or the recommended NFS CSI driver. For vSphere storage classes, the CSI provisioner and VCP provisioner are available, with in-tree provisioners being deprecated. Storage policy management can be used within Kubernetes with vCenter SPBM policies specified in the storage class. Virtual SAN policy support allows for custom virtual SAN storage capabilities during dynamic volume provisioning. Ceph RBD usage is deprecated, and the Ceph FS RBD CSI driver is suggested instead. Azure Disk and Azure File Storage classes also have deprecation notices, with third-party drivers recommended. Portworx volume and local volume storage classes have specific parameters for configuring storage, with local volumes not supporting dynamic provisioning in Kubernetes 1.31, but still requiring a storage class for delayed volume binding.